Land classification and assessment, an introduction to land classification. Rangelands encompass a diverse assemblage of land and vegetation types, including grasslands and shrublands, woodlands, forested systems, and deserts, as well as wetlands and riparian areas. We often gather information about rangeland vegetation and soils in order to assess the current condition or the ecological status of land. For example, we may be managing a management unit such as a ranch that you see outlined here, and we're managing the landscape, the vegetation, and the livestock resources on these lands. We may use subdivisions such as pastures in order to manage the vegetation and the livestock. But the land itself is not categorized or classified by these units of pastures, but instead may be better represented by classification systems that incorporate the information about the landscape, the soils, and the vegetation. We classify land so that we can organize information that we have in order to make decisions, in order to plan, to assess the condition or status of the land, and to make management decisions based on the condition of the land as well as our management objectives. We use a land classification system to describe lands, and we're going to be focusing on the NRCS land resource system. This is a land classification system that operates at multiple spatial scales, from very fine-scaled or small level of soil management units all the way up to a very broad level of land resource regions. The land resource system is informed by two primary information sources: the National Soil Survey Information System, or NASIS, and the Ecological Site Information System, or ESIS. The criteria that the NRCS land classification system uses for land classification varies at the different levels, but it incorporates land use and ownership, elevation and topography, climate, water resources, soils, potential natural vegetation, as well as typical disturbance regimes. At the broadest scale, we have the land resource regions. In the United States, there are 28 land resource regions, and these are generally defined by broad agricultural markets. The next level of organization are the major land resource areas, or MLRAs. These are geographically associated units that are all subunits of a land resource region. So each MLRA is incorporated in only one land resource region. Major land resource areas share similar climate, soils, geology, and biological resources. An excellent reference is the USDA Handbook 296, Land Resource Regions and Major Land Resource Areas of the United States, the Caribbean, and the Pacific Basin. So let's take a look at just a couple examples at this level of organization. Here we see Land Resource Region F, the Northern Great Plains Spring Wheat Region. It spans across 4 states and encompasses over 142,000 square miles. Geologically, it is united by sharing rolling hills that are of a glaciated nature. They generally have very fertile soils, but because of their position in the globally, latitudinally, they have a very short growing season. The range of precipitation is fairly narrow, between 14 inches to 21 inches, and this area is characterized by being windy in certain times of the year. In terms of land use, the land here is primarily used for croplands, pasture, and rangelands. And in terms of ownership, approximately 96% of this land is privately owned. This land resource region includes 9 major land resource areas, and so we're going to just briefly take a look at just a couple of them. To the west, the farthest west major land resource area is 52, the brown glaciated plain, and to the east and south we have the southern black glaciated plains. You can see from these images that they do share certain characteristics in that they are rolling hills dominated by grasslands. If we look at another land resource region, in this case the Western Range and Irrigated region, we see something quite different. This is the largest of the land resource regions. It spans across 11 states and encompasses nearly 550 square miles. It's predominantly desert or semi-desert in terms of its climate, and we can find a variety of landforms including plateaus, basins, plains, and mountains. The soils are generally aridosols and entosols with some monosols, and we can see that we would have very variable growing season because it does span from relatively far in the north all the way down to South Texas. The precipitation is also variable from being quite low at the Mojave Desert to higher up in parts of Northern California and also at higher elevations locally. One thing that unites this area is its use, and remember that land resource regions are pretty much defined by broad agricultural markets. This land is predominantly used as rangelands, or if it is farmed, it's irrigated farmland. Another thing that is different about this particular land resource region is that 60% of this land is federal land. This is a very diverse region, and so it is broken out into 23 MLRAs. Now, the next level of organization are the land resource units and common resource areas. These were originally developed as subdivisions of the major land resource areas. And land resource units were developed based on having similar climate. So what we see here is from MLRA 42, over here in this map of New Mexico, it shows 6 land resource units that were subdivided out of MLRA 42. The land resource units and common resource areas are the first aggregation of soil interpretation levels, such as ecological sites. Now, this part of the system is being revised by the NRCS, and so currently the land resource units and common resource areas cannot be used to identify ecological sites. So let's go to the next level, which are the soil interpretations. Now, these are the aggregations of soil map units. You may recall that soil map units are the foundation or the basis, the lowest level of the hierarchy of the land classification system that we are considering. Soil interpretation levels include ecological sites, forage suitability groups, wildlife habitat suitability groups, and other levels such as that. They generally have similar soils and a similar position in a landscape. Ecological sites are defined as a specific type of land that is capable of producing a certain type and amount of vegetation, and that has a similar response to management and disturbance. Here we see a map of a landscape that is divided out into different ecological sites. They're shown in different colors, and we see two that are highlighted here. The sandy ecological site generally has deep or moderately deep to deep soils that tend to be sands or sandy loams, and it's located on an alluvial fan or on a fan piedmont. Bottomland ecological sites also have deep to moderately deep soils. They tend to be clays, clay loams, and loams, and it's located in floodplains, on stream terraces, or on swales. So the soils and the landscape positions are very important in determining ecological site. The lowest level in this hierarchy are the soil map units, and these are the foundation for the land resource system hierarchy. StatsGo and SurGo provide the information for mapping either at a general or at a detailed level of soil map units. There's a relationship between ecological sites and soil map units. They are linked, ecological sites are linked to soil map unit components. Sometimes we can have different soil series phases in the same unit that are found on different ecological sites. So in this case here we see the stellar clay loam, 0 to 3% slopes, is associated with a clay ecological site, but the 40%, the stellar clay loam 0 to 3% slopes that's flooded is located in a bottomland site. We also have ecological sites can be groups of different soil map components. So for example, we see here the sandy ecological site can comprise different types of soils from the Barino-Doña Ana Soil Association or from the Oneinte Pajarito Soil Association. So let's see how we can use information about soils in order to determine an ecological site, because that is what we need to know for management purposes, is the identity of an ecological site. And we are going to look at a site on Otero Mesa in southern New Mexico. This is located in Major Land Resource Area 42. In order to do this, we're going to go to the web, and so I'm going to break away from the presentation here and bring up the Web Soil Survey. Now, from the Web Soil Survey, you start here by clicking on this button, and that brings us to a map of the United States. In order to locate our site, you can put in, and if you've already developed an area of interest, you can import that. You can include information about latitude and longitude, or information about section, township, and range. So we're going to use that approach. The Web Soil Survey doesn't zoom in and out nearly as well as Google Earth. There's a lot of information that's associated with it, and so it's far easier if you already know the coordinates of your site in order to start zooming in order to find your site using the Web Soil Survey. So I've just entered the township, range, and section information for the site that I am interested in looking at. And so we see it here. Now, I do want to zoom out a little bit, and what I would recommend to you is what we do is we click up here on Zoom Out. You then click on the image in Web Soil Survey just once. It will remember how many times you've clicked, and if you click many times, the next thing you'll know, you're looking at a map of the entire United States, and you have to start over again. Okay, so this is the general area that I'm interested in. There's a ranch here, and I want to learn about some of the soils in this general area here. So what I'm going to do is I'm going to use this polygon tool to develop an AOI, which stands for Area of Interest. And the way that this works is you click up there, and then you just start clicking on the map to different locations around this map unit. I'm going to come over to approximately here, and then up to here, and then maybe just kind of follow this fence line over to about here, and there. And so then by double clicking on that, it's going to create the AOI for me. Sometimes this can take a couple minutes. Here we see the area of interest is outlined here, and I can save this if I like as a permanent AOI. That way I can bring it back in the next time I want to. So I'm just going to call it the Otero Mesa Site 1. And I can save that or export that. I'll do that in a minute. What I'd like to do now is look at the soil map that we have of this AOI that we have created here. We can see that this area is fairly large, and it includes 4 major soil types, mostly 2. We have 54% filter, very fine sandy loam is located here. It's a little bit hard to see, but the different soil types are outlined in orange here. And so everywhere where we see the PEC, we have filter, very fine sandy loam, and everywhere where we see the RFA, such as up here and here, that is the RAAB Armisa Association. So let's get some information about these soils, because remember, what we want to do is use this information to help determine what is the ecological site. In this case, when I click on this, on the name of the soil, a map description, soil map description comes up for the filter, very fine sandy loam. It provides information about the setting, about the landform, so this is on a fan Piedmont generally, and other information about the site. Provides information about the typical soil profile, so very fine sandy loam, grading down to gravelly silt loams and very gravelly silt loams. But a piece of information that's very important here is that it identifies the ecological site as gravelly, and it provides the site identification number. So I would record that and use that information in the future. Now let's look at the other soil unit that is most common on this site, and this is the RAAB Armisa Association. So this is an association of, it's a composite soil map unit. The RAAB and the Armisa intergrade so much that they don't map it out individually, but map it as a composite or association. And it's generally 60% RAAB soils and 35% Armisa soils. We then see a description of the RAAB soils. Again, it's on Fan Piedmont, gives information about the typical soil profile, but also tells us that this particular soil type is generally associated with a draw ecological site, and it has a different site identification number. If we continue to scroll down, we now see the description of the Armisa. Again, it's on the same kind of a land form. There's information about soil properties and the typical soil profile, but we can see that the Armisa site is generally associated with a limey ecological site. So on this particular AOI, or area of interest, we've identified 3 possible ecological sites: the limey site, the draw site, and the gravelly site, that are associated with this one area of interest. Now, because of the scale at which map units are drawn, it's important that we go to the site and verify the ecological site. You cannot determine what an ecological site is in most cases simply from looking at a map. And of course, we would be going to the site anyway in order to characterize other information about the vegetation. So here we see the AOI with the different units highlighted, and we would want to go to that site and verify the identity of the ecological site at whatever location where we wanted to do our sampling, so that we were sure that we had clearly identified that site. There will be more information about ecological sites and about the assessment of ecological sites in the following lesson. So in conclusion, the NRCS land classification system is a hierarchical system that classifies land from very broad scales, the land resource regions, through major land resource areas, to ecological sites and soil map units. And we can use this land classification system in order to clearly identify the type of land that we are on when we are trying to characterize information about the site and gather information so that we can assess the current condition and ecological status of the land.